Any idea like what we are going to study in this chapter? Like
Yes, ma'am.
what shall we study in this chapter? What will be the topics?
Ma'am, how the Newton's laws.
Exactly. The main important topic in this chapter is Newton's laws of motion, free body diagrams, and mainly the numerical part. Okay.
Yes, ma'am.
So first we'll see the introduction and all in today's class, and tomorrow we'll go for problematic part. Okay. So what do
Yes,
you
ma'am.
mean by motion? Basically, motion is nothing but movement of an object. Okay.
Yes.
Movement of a body from one place to another place is called what? Motion. Okay. Now, related to that motion of a body, Newton has understood certain things and he formulated certain principles, and those are called Newton's laws of motion. Okay,
Yes, ma'am.
we call them as Newton's laws of motion. And how many Newton's laws of motion we will be having? We'll be having three Newton's laws. Okay,
Yes, ma'am.
so first law, second law, and third law. Okay, so before that, we will have some introduction. So, if you study the movement of a body without knowing the reason for its motion, without knowing the cause of its motion, like why the body is moving, did somebody push it or pull it, you don't know the reason behind it, you just simply study about movement of a body. So in that case, what do we call it? We call it as kinematics, the study of the motion of a body without knowing the cause of its motion. Okay. And
Yes,
second
ma'am.
thing, you will be studying the motion of a body, also the cause for its motion. Then what do we call such branch of physics? We call it as dynamics. Okay. So
Our
motion of
laws.
motion of a body is studied under two branches of physics. One is kinematics, the other is dynamics. In both the subjects, we'll study about motion of the body only. But in kinematics case, we don't bother about the reason behind the motion. But in dynamics case, we just consider also the cause for it. Okay. Now,
Yes, ma'am.
so can you tell me what could be the reason for motion of a body? Like why a body will move or when a body will move, what could be the reason behind it?
When an external force acts.
Exactly. So when a force acts on a body, the body tends to move, right? So what is
Yes.
force here? Force is nothing but a push or a pull. It can be a push or it can be a pull. Okay. So pushing in the sense it will move in forward direction, pulling in the sense it will move towards yourself. For suppose there is a block which is kept on a floor. Okay. This block is having mass m. Now you are pushing it. Pushing it in the sense what? This is the push. That means the object will move in forward direction. Okay. And this
Yes.
is called pulling. Green color one is called pulling. Pulling in the sense what? It will be moving towards yourself. For suppose here is Gautam. So who is exerting force on the object? So there are two kinds of force. One is push, the other is pull. If you push, the body will move in forward direction. If you pull it, it will move towards yourself.
Yes.
Okay. So push or pull is nothing but a force, and what will be the consequences of force whenever you apply a force on a body? What happens to this body? If it is at rest, it will undergo motion. If it is in motion, maybe it will come to rest position or maybe it will increase its speed. Different things will happen. Okay. So maybe it
Yes.
changes its state of rest, or maybe it changes its state of motion, or sometimes maybe it changes its direction. Clear? So force can
Yes.
do all these kind of things. For suppose I'm sitting Gautam. After the class I have to get up. So I'll apply some force. So what am I doing here? I'm changing my state of rest. Now I turn into motion. I'm
Yes.
walking, I reached my home and I'll sit on the chair. So this time what happens? I'm changing my state of motion. I was walking, now I have stopped. That means I'll come into rest position now. I was driving a vehicle, I just took a U-turn. So what am I doing there? I'm changing my direction. So to change the rest to motion or motion to rest or to continue the motion with greater speed or to change the direction, in all these cases what we need to apply on the body? We need to apply force on the body.
Yes.
Is this point clear?
Yes, ma'am.
Okay. So now these forces are classified into two types depending on whether the objects are in contact or not in contact. Depending on that, we are having two types of forces. Okay. So forces are basically classified into two types. Number one, contact force, and number two, non-contact force. You have any idea about this?
Yes, ma'am. Which have physical touch is contact, ma'am. Which does not have physical touch.
Yeah. So whatever it is, for suppose if you take the previous example, you are applying the force and you are applying force on the block. So you two will be the interacting objects because you are
Yes.
applying force, object is receiving the force. Who is applying, who is receiving, those two are called interacting objects. Okay.
Yes, ma'am.
So when you take contact force, what happens? The interacting objects will be in contact. Interacting objects will be in contact with each other. Interacting objects means what, Gautam? The one who is applying the force and the one who is receiving the force. Both of them
Yes.
are called interacting objects. And what about non-contact force?
Ma'am,
Interact
which interacting objects will not be in contact.
exactly. Interrupting objects are not in contact here. They are not in contact. Now, what are the examples of contact forces?
Ma'am, muscular force.
Number one, muscular force. Number two, normal force. Normal force is also called normal reaction. Okay. And number
Okay.
three, elastic force. Elastic force means spring force, the force in a rope, wire, all of them. Okay.
Yes, ma'am.
Elastic force, and what was given to you? Frictional force. Now, what about the examples of non contact force? Gravitational force,
Yes, ma'am.
and then magnetic force. Magnetic force is also called electromagnetic force. Okay.
Yes, ma'am.
Now,
Ma'am, electrostatic force.
exactly, electrostatic force, nuclear force. In your textbook, weak force is given, but that is also a kind of internal force in an atom. Okay. We don't
Okay.
consider it exactly as non contact force. It's a part of nuclear force only, but nuclear force is very strong. Weak force is very weak, but both operate within an atom. Okay.
Okay, ma'am.
Now, so what is this muscular force, Gautam? Like the force which is exerted with the help of our muscles. Like, I want to lift a rice packet, I want to get vegetables, I have to raise the accelerator. In all those cases, what am I doing? I'm exerting the force with the help of my muscles, right? So
Yes, ma'am.
that's called muscular force. Now when you take normal reaction, what is normal reaction? Like you kept a book on a table. Okay. Now this non-living objects exert some force. The book will not fall down due to gravity. Why? Because the table is supporting it. Such kind of supporting forces are called normal reactions. Okay. I can simply
Yes.
say here supporting forces. Supporting forces are called non-react normal reactions. And muscular force is a force which is exerted with the help of our muscles. Okay. Now, elastic force. What is this elastic force? When you apply a force on an object, if that object undergoes any change in its shape, for suppose I'm stretching a rubber, I'll just take my hairband, I'll just twist it. In all those cases, what happens? The shape of the object is changing, right?
Yes, ma'am.
So the force which brings a change in the shape of an object, that is called elastic force. Elastic force, what does it do? It brings a change in shape of an object. Shape of object. Now, what about frictional force? We have studied much about this, right? The force which acts in opposite direction. And what is a condition for frictional force? The two bodies must be in relative motion. If the object is moving forward direction, frictional force will be in backward direction. And we
Ma'am,
also,
and tangential to this.
yeah, tangential to the point of contact. And we also have studied that friction is necessary in some cases and it is a drawback in some other cases. Like if I want to write now, if I want to walk on the ground, in all those cases friction is helpful. Okay. In some other cases, what happens? Friction produces lot of heat in industries, In missions and all, friction is a drawback. It produces lot of heat, power loss will happen, efficiency of mission decreases. Do you remember we have studied all these things?
Yes, yes, ma'am. Yes, ma'am.
Okay, so frictional force is an opposing force. This is important. Any doubt in all these contact forces?
Ma'am, but it opposes a relative motion.
Yeah, opposes the relative motion of the body. Yes.
Now, opposes the motion is different and opposes the relative motion is different.
Opposes a relative motion is important. Relative motion in the sense what? There must be, what should I say? Relative in the sense with respect to the other object. That is the meaning of relative.
Okay, ma'am.
Relative, why it's called relative? Suppose if I take an object in air, will it be in contact?
No,
It
ma'am.
is moving in the air, but frictional force, air friction is neglected here. It will be having very lesser value. It won't be considered. Okay. And relative motion, in your class you will study that maybe the block is moved on a floor, maybe the block is moving on a table. But when you go to higher classes, you will study these kind of questions. This is table, and there is one block here, and there is one more block on it. Okay. So block 1 is moving in forward direction. So what will be the direction of friction in block 1? This is the direction of friction in block 1, right? Now,
Yes.
because of the movement of block 1 in forward direction, there will be a jerk. You have studied Newton's law of motion, right? If 1 is
Yes.
moving forward, 2 will move in backward. So this is the
Yes, ma'am.
direction of the motion of block 2. Now in this case, what will be the friction direction on block 2? It will be in forward direction.
Yes, ma'am.
So this is the meaning of relative. Why it
Yes.
relative motion in the sense, if you use only block 1 with respect to table, there is no importance of relative word. But when you take group of blocks, in contact with each other, because of one there is an impact on second block. So in that cases, what we have to do, we have to consider relative motion. Of course, we have applied the force, main force is applied on block 1, but are we deciding the direction of friction only with respect to external force? No, we are
No, no.
deciding with respect to the motion of the blocks.
Yes, ma'am.
That's the meaning of opposing the relative motion.
Yes, ma'am.
Got this point? Generally what people will think, force is in forward direction, so friction is in backward direction for 1 and 2 blocks, but that is wrong.
Yes, ma'am.
Okay, because of the first block, second block is moving in backward direction, so frictional will be on forward direction in second block, backward direction in first block.
Ma'am, how second block will move back?
Newton's law, beta, action reaction. If one is moving forward, what happens to the two?
Yes, ma'am. It will
O-
move backward.
Opposite directions, no?
Yes, ma'am. Yes.
Okay. See, in some cases, two also will move forward. Like if you apply greater force, and if block 2 is having lesser mass, that possibility is also there. If the block 2 is having very small mass, that will also move along with the one. In that case, what happens? Frictional force on block 2 is also backward direction.
Yes, ma'am.
Okay,
Understood.
so there are two cases, but in order to make you understand the word relative, I just took this example.
Okay, ma'am.
Okay, so any doubt in contact force?
No, not all.
Okay, now when you come to non-contact force, what is this gravitational force? It's the force which acts between any massive objects. Okay, like between you and me, like between you and your mobile phone also, there will be gravitational force. But why don't we feel it? Why don't we attract it? Because our force is very less. All the time
Yes.
we say it's a force exerted by earth, but this is not true. It can be between any massive objects. Any object which is having mass can exert this gravitational force. Why we consider only earth, the sun, such kind of bigger bodies is because they are big in size, they are having huge mass, so that's why their force is felt by us. Like if you
Yes.
take planets revolving around the sun, it's because of gravitational force. Moon revolving around the earth, it's because of gravitational force. When you leave an object in air, it will fall down. That is also because of what? Gravitational force.
Yes,
Between
ma'am.
me and now computer also there is gravitational force, but why don't computer attract towards me? Because my
It is.
gravitational force is very less, my mass is very less, so gravitational force is also very less. It is not sufficient for attracting.
Yes, ma'am.
Okay. And what will be the direction of gravitational force? It will be towards the center of the earth. First force, what will be the direction? It will be towards the center of the earth. You have studied in social, right? Earth is made up of three different layers: crust, mantle, and core. So again, in the core, the center point we have to consider. Always the direction of gravitational force is towards the center of the earth. Okay.
Yes, ma'am.
Now, what is magnetic force? It's the force which is experienced through magnets. Like you
Yes.
take a magnet and you try to attract the objects. Then what do we call it? It's nothing but magnetic force.
Yes,
Okay.
ma'am.
And magnetic force, there will be two types again. There will be Fa, attraction force. There will be Fr, repulsion force. So when do we see attraction force? If opposite poles are facing each other. Second
Yes,
case,
ma'am.
if north pole of one magnet is facing south pole of another magnet, then we will have attraction force. If north pole of one magnet is facing north pole of second magnet, or south pole of first magnet is facing south pole of second magnet, then we will see force of repulsion.
Yes, ma'am.
Okay. The same way, if you take electrostatic force, it's because of the charges. You know, right? Electrons, protons, charges. So when
Yes,
you
ma'am.
take any body, Gautam, that will be having all these fundamental atoms, and they are made up of some charged particles. If there is an unbalance, like electrons are more in the body, or maybe protons are more in the body, if there is any unbalance, then we can expect this electrostatic force.
Yes, ma'am.
Okay. Like if you take positive charge, another positive charge, repulsions will be there. One positive charge, if you take another negative charge, then there will be attraction force. So here
Yes,
also, if you take same charges, what type of force will operate? Fr, repulsion force. If you take opposite charges, then what kind of force will operate? Attractive force, Fa. If you take one positive, one negative, then attraction force. Okay. Electrostatic force is because of the charges. Magnetic force is because of magnets. Okay. Nuclear force. You have studied about nucleus in an atom, right? Atom will
yes,
be
ma'am.
spherical in shape, and at the center of an atom you have nucleus, and that nucleus is made up of what particles? It is made up of neutrons and protons, right?
Yes, ma'am.
Now, neutrons, do they have any charge?
No, ma'am.
No.
Chargeless part.
Yeah. What about protons?
Positively charged.
Positively charged. And just now I told you about electrostatic force. If there are same charges, they must have repulsion force. Now, when you take nuclear force, in the nucleus we have all positive particles, right? So
Yes,
they
ma'am.
must experience what kind of force? Force of attraction or force of repulsion?
Force of repulsion.
Yeah, they must experience force of repulsion. For suppose if I assume this as a nucleus will be very small, but I'm just taking big for understanding sake. Okay. So protons, neutrons, all will be present. So this is positive, positive, positive. So according to electrostatic force concept, there must be repulsion here. Okay. So due to
Yes, ma'am.
repulsion, what should happen to the protons? They must go far from each other, and nucleus size must increase, and at some point nucleus must break down.
Ma'am, they can be positive, negative charge also, right? They can be attract also, right?
Where is the negative charge here? Electrons will be outside the nucleus, right? Electrons are revolving around the nucleus in the shells, right? They are not inside the nucleus.
Yes, ma'am. KHL.
Okay, so if you take electrons in the shell, between electrons to nucleus, there is an attraction force, fine. But if you take within the nucleus, proton to proton, there must be what? There must be repulsion force. So if you consider that concept, protons must go far from each other and nucleus must break down. But is it happening in reality?
No, ma'am.
No. So what could be the reason? Scientists have thought that of course there will be force of repulsion, but higher to that, greater to that, bigger than that, we have a stronger attractive force that is called nuclear force. Stronger force of attraction than the force of repulsion is present in nucleus. What is this stronger force of attraction? This is called nuclear force, the force which operates within the nucleus of an atom. It is present within the nucleus of an atom. Now this nuclear force is between proton to proton, neutron to neutron, proton to neutron also.
Yes, ma'am.
Okay, it is between the nucleons. What are these protons and neutrons? The particles which are present in the nucleus, they are called nucleons. So which
Yes.
operates between nucleon particles, that's called nuclear force. So definitely there is force of repulsion, but that repulsive force effect is not seen. Why? Because greater than that we have attractive force. What's that attractive force? It's nuclear force. Okay,
Yes, ma'am.
clear?
Yes, ma'am.
Any doubt?
No, no doubt, ma'am.
Okay. And when you take fundamental particles in an atom like electron, proton, neutron, there will be certain deformations, Gautam, like electron changing into proton, proton changing into antino, such kind of transformations will be there, that we will study in radioactivity chapter. But as of now, you just have a little clarity. Okay, so between
Yes.
fundamental particles, whatever the forces act, they are called weak forces. The other category is weak forces. It operates between fundamental particles. What are fundamental particles? Electron, proton, neutron. Okay,
Yes.
between fundamental particles. And because of this force, what will be the consequences? There will be transformations, like electron changes into proton, proton changes into some other particle, neutron changes into antineutrino. Such kind of transformations will be there, which we will study in radioactivity. In your chemistry, you will study this. Okay,
Yes, ma'am.
so any doubt about the different categories of forces?
No doubt, ma'am.
All clear?
Yes, ma'am.
Okay, now we will enter into the main topic of this chapter, that is Newton's laws of motion. Okay, first we'll take Newton's first law of motion. You have any idea about this?
Ma'am, F is equal to M.
Newton's first law, F is equals to ma, is Newton's second law. Okay,
Okay.
I have a doubt, you must clarify me. Okay, I have two questions for you. Okay, now imagine you have a car, Gautam. Okay, you have parked in the cellar. Now you want to come to my home, so you have to start your car, right?
Yes, ma'am.
So if you don't apply the force with the help of engine, do you think your car will start?
No, ma'am.
No. So what I have to do now, you have to understand one point. If an object is at rest, if you want to get it from rest into motion, what you have to apply here?
External force.
You have to apply force. Is this point clear?
Yes, ma'am.
No. Second thing, imagine that you are near to my home. Now you have to stop the car, you have to apply the brakes. So if you don't apply the brakes, in the sense, if you don't apply the force with the help of brakes, will your car stop?
No, ma'am.
No. That means if you want to make the object from motion into rest position, how is it possible? Again, you have to apply the force,
Force.
right? Now I have a question. If you don't apply the force, then what happens? First
It
point.
will,
Yeah,
will keep on.
yeah, if you take first point, rest object will be in rest position only. The body which is in motion will be in motion only. If you don't apply the force, there won't be any change in its state, right? If it is in rest, it will continue rest. If it is in motion, it will continue motion, right?
Yes, ma'am.
So this is nothing but your Newton's first law of motion. What Newton said is, unless and until we apply some external force, there will not be any change in the state of an object. That means the object which is in rest will be in rest only. Object which is in motion, it will be in motion only, unless and until you apply some force. If
Yes,
you
ma'am.
apply force, then only it will change its states. If you don't apply the force, it won't change its state. That is the meaning of Newton's first law of motion. Clear?
Yes, ma'am.
Okay. Any doubt in this?
No, no doubt, ma'am.
Now, so I just want to ask you one more thing. Like if you take the first point, the body is in rest. It is trying to be in rest only if you don't apply the force, right?
Yes, ma'am.
Even if you apply the force, internally the body tries to be in rest only,
Yes, ma'am.
because it don't want any changes. Of course it will change, of course it will come into motion in reality, but internally what body will be trying to do, Gautam? It will try to retain its state. Okay, there
Yes,
will
ma'am.
be change definitely, but internally the object It just tries. It will not succeed, but it just make an attempt. It tries to be in the same state. Okay, the object
Yes.
tries to be in the same state. What does it mean? You apply the force, it will become rest to motion or motion to rest. That is pakka, that is clear. But what body will be trying to do? Array yaar, somebody applied force on me, let me be in rest, let me be in motion. So it will think like that, it will try for that. Okay,
Yes, ma'am.
so this action of the body or this tendency of the body to continue the same state is called inertia.
Okay, ma'am.
So what is this inertia? It's the tendency of a body to continue its state. Continue its state. To continue its state. But will it continue in the same state? Definitely no, because you have applied the force. But
Yes,
it
ma'am.
but it tries for it. It tries for it, but it won't remain in the same state. Okay.
Yes,
So
ma'am.
tendency of a body to continue its state, or tendency of a body to oppose the change in its motion or change in its rest position, that is your inertia. Okay. And any
Yes,
doubt
ma'am.
in this?
No, no doubt.
So when you take Newton's first law of motion, if you take the first point, you are changing rest into motion with the application of force. That means what body is trying to do here? The body is trying to remain in rest only,
Yes, ma'am.
but it won't get success. If you take point 2, we are changing the motion of a body into rest position with some application of force. But what body will be trying to do in second case? It will try to continue its motion only. But
Yes,
will it
ma'am.
continue?
No, ma'am.
No, it will definitely change, but it was trying for it. Okay.
Yes, ma'am.
So if it is trying to continue its state, if it is trying to continue its state of rest, it is called inertia of rest. Okay. If it is trying to continue its state of motion, it is called inertia of motion. Are you
Yes.
understanding this, Gautam?
Yes, ma'am.
బాడీ తన స్టేట్ని చేంజ్ చేసుకోకుండా ఉండడానికి ట్రై చేస్తుంది, కానీ సక్సెస్ అవ్వదు.
Oh, yes, ma'am.
రెస్ట్ పొజిషన్లో ఉంది, మనం ఫోర్స్ అప్లై చేస్తాము, బాడీ మూవ్ అవుతుంది. కానీ అది ఏం ట్రై చేస్తుంది? మూవ్ అవ్వకుండా ఉండడానికి ప్రయత్నిస్తుంది, కానీ ఫోర్స్ అప్లై చేయడం వల్ల వెళ్ళిపోతుంది అంతే. బాడీ
Yes, ma'am. Yes.
మోషన్లో ఉంటుంది, మోషన్ని కంటిన్యూ చేయడానికే ట్రై చేస్తుంది అది, కానీ మనం ఫోర్స్ అప్లై చేయడం వల్ల ఏమవుతుంది? రెస్ట్ పొజిషన్లోకి వచ్చేస్తుంది. ఆ
Yes,
ట్రయింగ్ని
ma'am.
మనం ఏమంటామంటే ఇనర్షియా అంటాం. So if you take the
Yes.
first point, it is at rest position. So what it will do? It will continue to be in rest only. So first point, what do we consider? We consider inertia of rest.
Next is inertia of motion.
Yes, exactly. The body is in motion. Starting point is motion. So it will continue to be in motion only. So what
Yes,
will
ma'am.
be considered here? Inertia of motion. Okay. Let us take some other case. Body is moving with the same speed, but it is trying to change its direction. అప్పుడేమొస్తుంది? Inertia of direction.
Direction. Yes.
It is already in motion, but what is the change that we are bringing with some force? We are trying to bring a change in direction. సో బాడీ
Yes,
ఏం
ma'am.
చేస్తుంది? అరే వీడు నన్ను డైరెక్షన్ చేంజ్ అని ట్రై చేస్తున్నాడు, నేను సేమ్ డైరెక్షన్లో ఉండడానికి ట్రై చేయాలి అనేది ట్రై చేస్తుంది అనమాట. ఇట్ ట్రైస్ టు బీ ఇన్ ద సేమ్ డైరెక్షన్. సో
Yes,
దేర్
ma'am.
వీ కన్సిడర్ వాట్? ఇనర్షియా ఆఫ్ డైరెక్షన్.
Yes, ma'am.
Okay, so in Newton's first law of motion, directly or indirectly, we are dealing with the concept of inertia, right? So
Yes,
Newton's
ma'am.
first law of motion is also called law of inertia.
Yes, ma'am.
This is also called what? Law of
Of
inertia. Any doubt in this, Gautam?
no, no doubt.
చాలా ఇంపార్టెంట్, అందుకే నీకు తెలుగులో కూడా చెప్తున్నా నేను.
Yes, ma'am. Understood.
Okay, now so we'll see some applications of Newton's first law of motion. Now you have to tell me which point is considered here. Okay,
Yes, ma'am.
whether it is inertia of rest or inertia of motion, you have to tell me. Applications of law of inertia. Law of inertia means what? Newton's first law only.
Yes, ma'am.
Okay, don't confuse. Law of inertia means first law only. So first point, so you are standing in a bus. Okay, Now bus
Yes, ma'am.
starts suddenly.
Thoughts. Yes, ma'am. Means it is in rest only.
Yeah. So it is starting suddenly. So what is your initial state?
Rest, ma'am.
Initial state is rest. So when bus is starting suddenly, in the sense bus driver has applied some force, right?
Yes, ma'am.
So what happens to your rest position now? Your rest position changes into motion. Why? Because of the application of force. Applied
Yes,
force,
ma'am.
the bus is in rest, the bus which is in rest, now it is getting into motion. Okay. So according to law of inertia, now what happens? You are actually in rest position. So your body tries to be in rest only, right? Initial state rest.
Yes, ma'am.
So inertia prakaram emautundi, your body tries to be in rest only.
Yes, ma'am.
Okay, so here what do we consider? We consider inertia of rest.
Yes, ma'am.
So suddenly you will fall backward. You will fall backward.
We tend to fall backward. Yes.
Enduku bus is in moving in forward direction. So due to
Yes,
inertia
ma'am.
of rest, inertia of rest అంటే ఏంటి? నీకు ఏమైతే చేంజ్ చేస్తున్నారో ఆ చేంజ్ కి అగైనెస్ట్ గా నీ బాడీ బిహేవ్ చేస్తుంది. Now
Yes, ma'am.
now now along with the bus your body is pulled in forward direction. So according to
Yes.
inertia of rest your body must oppose that. So where will you go now? You will go in backward direction.
Yes, ma'am.
Is this point clear, Gautam?
Yes, ma'am.
And which inertia is considered here? Inertia of rest.
Yes, ma'am.
Any doubt?
No, no doubt.
Now you consider the same bus. Okay. So the bus is in already motion. Now you are
Yes.
standing. Same. Bus is already in motion and it is moving in forward direction. Okay. Now we just consider that suddenly brakes are applied.
We fall forward.
Brakes applied. Okay. Now what is the starting state of yourself? Bus is
Motion.
already in motion. So your initial state is what? Your initial state is motion. So your body tries to be in motion. That's it. నీకు ఇనిషియల్గా ఏముందో అదే నీ బాడీ కంటిన్యూ చేయడానికి ట్రై చేస్తుంది. యూఆర్ ఆల్రెడీ ఇన్ మోషన్. సో వాట్ డూ వీ కన్సిడర్ హియర్? వీ కన్సిడర్ ఇనర్షియా ఆఫ్ మోషన్.
Yes, ma'am.
Okay, now brakes are applied. So if brakes are applied, what happens? Suddenly the bus will stop now.
Yes, ma'am.
So what happens to you now? When the
We
bus
fall.
is, yeah, when brakes are applied, bus will not move forward now. It will try to pull the bus backward. That's it.
Yes, ma'am.
It won't move back, but when you apply the brakes the force is applied in opposite direction. బస్సు ఫార్వర్డ్ మూవ్ అవుతుంది, స్టాప్ అవ్వాలంటే బ్రేక్స్ ఏం చేయాలి? ఆపోజిట్ డైరెక్షన్ లో ఫోర్స్ ఉంటుంది.
Yes, ma'am.
సో హియర్ ఫోర్స్ ఇస్ ఇన్ ఆపోజిట్ డైరెక్షన్, సో అవర్ బాడీ విల్ మూవ్ ఇన్ ఫార్వర్డ్ డైరెక్షన్.
Yes, ma'am.
Is this point clear?
Yes,
even
ma'am.
even if there is a small doubt, ask me, Gautam. This topic is important.
No, no doubt.
Okay, now we'll see some other examples. When you take a car, turning under a steep road, what happens? You will fall left side or right side. What is that inertia? That is inertia of direction.
Yes, ma'am. Direction.
Okay, so
Because it is a steep turn, right, ma'am?
yeah, our body tries to be in the same direction, but application of force, our body direction changes, we want to get it back, that's why we also bend.
Yes, ma'am.
Now third example. So let us take any fruit. In your textbook it was given mango. Okay, so when you shake the branches of a tree, mangoes will fall down. Why?
Ma'am, because inertia of rest, ma'am.
Inertia of rest. Because before you shake the branches, what was the initial state? Initial state is rest. So it tries
Yes,
to
ma'am.
be in rest only. So that is why inertia of rest. Branches ని మూవ్ చేసినప్పుడు branches తో పాటు ఫ్రూట్స్ మూవ్ అవ్వవు. ఎందుకు? ఫ్రూట్స్ tries to be in the rest only.
Yes,
సో
ma'am.
మూవ్ చేసినప్పుడు ఏమవుతుందంటే కనెక్షన్ విల్ బి లాస్ట్ అండ్ దట్ ఈస్ వై మ్యాంగోస్ విల్ ఫాల్ డౌన్.
Yes, ma'am.
The same thing with our door carpet also. Door carpet also, it will be having some dust particles on it. Okay, so what do? We just beat it against the wall. బయటకి తీసుకుపోయి డోర్ కార్పెట్ ని పటా పటా కొడతాం. ఎందుకు? Because when you do that, door carpet is undergoing motion, but dust particles they try to be in the rest position only. That is why they fall
Inertia
down.
of rest only, ma'am. Inertia of rest.
So here also what do we consider? Inertia of rest only.
Yes, ma'am.
Inertia of rest here for mangoes and here for dust particles. Is it clear, Gautam?
Yes, ma'am.
And many other examples are given in your book, like manam grinding stones. ఏం చెప్పాలి నీకు, కత్తిపీట చాకుని షార్ప్ చేస్తారు చూడు, ఇంటికి వచ్చి చెప్తారు వాళ్ళు. So there,
Yes, yes,
there
ma'am.
will be a stone which will be rotating, and they'll keep this knife on it. So knife becomes sharp. So if you see, sparks will be coming out in circular motion, tangential direction.
Yes,
So
ma'am.
so that's an example of what? That's an example of inertia of direction.
Yes, ma'am.
Okay. Similarly, when you take carom board, when you hit the bottommost coin goes. But what about the remaining coins, remaining pile of coins about to hit? They just fall down in the same place.
Yes, ma'am.
Okay, because that is inertia of rest. The above
Yes,
coins, they want to continue the same state of rest. Though
yes,
we
ma'am.
try to bring a state of motion by hitting, they want to remain in the rest position only. Okay. So
Yes,
all
ma'am.
these are examples of Newton's first law of motion. Ante, unless and until you apply the force, there is no change in the state. Let it be state of rest, or let it be state of motion, or let it be state of direction.
Yes, ma'am.
Clear? Any doubt in this?
No, no doubt.
Okay. Now we'll go for Newton's second law. So Newton's second law is something related to momentum of a body. So first we'll see what is momentum, then I'll explain you Newton's second law. Okay.
Yes, ma'am.
You have any idea about momentum?
Ma'am, momentum mass into velocity.
Mass into velocity. That is actually linear momentum. When you get into higher classes, you will also study about angular momentum. Okay.
Yes, ma'am.
So the one which is given in your book is linear momentum. Ante body motion is considered to be in straight line. If the
Yes,
body
ma'am.
is moving in circular path or maybe in triangular path, rotatory path like giant wheel and all, we don't consider linear momentum. We consider angular momentum. Okay. So for your 8th standard, only linear momentum is given. So
Yes,
what
ma'am.
is this linear momentum? It is denoted with the letter P. It is defined as the product of mass and velocity.
Yes, ma'am.
Okay, so P is equals to M into V. This is its formula. Okay, and what will be the units of P now? We have two different system for units: CGS system, MK
Okay.
system, or system of international units.
From
CGS,
kg.
yeah, mass CGS unit is gram, velocity CGS unit is centimeter per second. Getting my
Yes,
point?
ma'am.
Okay.
Yes, yes.
P is equals to MV కదా. MV కేమ్ యూనిట్స్ ఉంటాయి, P అదే యూనిట్స్ ఉంటాయి. Mass is gram, velocity is centimeter per second.
Yes, ma'am. Understood.
Now MKS are SI units. Mass is kilogram, velocity is meter per second. So total unit of momentum is gram centimeter per second or kilogram meter per second.
Yes, ma'am.
Clear?
Yes, ma'am.
Okay. Now what else is important? Yeah, about their direction. When you take mass, is it a scalar quantity or vector quantity?
Mass is
Mass is a
scalar.
scalar. Yeah, mass is a scalar quantity because it do not have any direction. What about
Velocity is
yeah, velocity is a vector quantity. Now when you take the product of scalar quantity and vector quantity, the resultant will be what? Resultant is also vector quantity.
yes, ma'am.
Okay.
So momentum is vector.
Exactly. Okay, so momentum P is also a vector quantity now. Vector quantity means it will have the direction, right? So
Yes,
what will
ma'am.
be the direction of momentum? The direction of the force itself.
Yes,
మనం
ma'am. In
బాడీ
this,
మీద ఫోర్స్ ఏ డైరెక్షన్ లో అప్లై చేస్తే మొమెంటం కూడా ఆ డైరెక్షన్ లోనే ఉంటుంది. ఓకే,
yes,
సో
ma'am.
వాట్ విల్ బి ఇట్స్ డైరెక్షన్? Its direction is same as the direction of force.
Yes, ma'am.
Direction of a force applied on the body.
Yes, ma'am.
And what else is important? Okay, so one more concept is given in your textbook. Like if you take momentum, it is depending on two quantities. One is mass, the other is velocity, and both are important. Okay, like if you
Yes.
see here, both are on numerator, right? Left side p is in numerator, right side m and v both are in numerator. So what does it mean? So if mass is increasing, momentum also increases. If
Yes.
velocity increases, momentum also increases, because momentum is directly related with both mass and velocity.
Yes, ma'am. It is
So
directly proportional.
directly proportional to mass, also directly proportional to velocity. Like if you take a bus, empty bus, and the bus which is having full of passengers, so which will give more momentum?
Where more mass means full
Where
of
more,
bus.
yeah, where the bus is full of passengers, because bus weight, passengers weight, mass is more, so momentum will be more.
Yes.
Similarly, when you take mm a bullet moving with high velocity and a bullet moving with less velocity, so which will have more momentum?
High velocity.
High velocity. Suppose running competition is kept in your school, you are running with 5 kilometers per hour speed, your friend is running with just 2 kilometers per hour speed, so who is having higher momentum?
Myself.
Yourself will be having higher momentum. Got this point?
Yes, ma'am.
So momentum is directly proportional to mass, also directly proportional to velocity. It means that both will affect the momentum. అంటే రెండిట్లో ఏది చేంజ్ అయినా మొమెంటంలో చేంజ్ వస్తుంది, అది గుర్తుపెట్టుకోవాలి నువ్వు. మాస్
Yes, ma'am.
చేంజ్ అయినా వెలాసిటీ చేంజ్ అయినా both will affect the momentum value. Okay,
Yes, ma'am.
now we'll study about Newton's second law. As you said, F is equals to ma, that is Newton's second law. Okay,
Yes, ma'am.
Newton's second law of motion. When somebody asks you what is Newton's second law of motion, you must not say F is equals to mva. That is just a formula for Newton's second law. Statement ఏంటి అంటే, the rate of change of momentum, the
This
rate of,
direct.
yeah, the rate of change in momentum is directly proportional to the net force acting on the body. What do you mean by net force?
Total force.
Yeah, you have to consider total force. For suppose on the body, two forces are acting. One is in forward direction, the other is in backward direction. Then you have to take subtraction of them.
Yes, understood. Yes, ma'am.
Okay, net force acting on the body. So momentum symbol is what? P.
P.
Change.
Yes, ma'am.
Change symbol is delta. This is change symbol. Rate means with respect to time. Okay. Now
Yes.
momentum is P. Change in momentum delta P. Rate means with respect to time. That means when time is changing, momentum also changes.
Yes, ma'am.
Like if you take starting of a car, initially zero velocity. But when you start the car, what happens? Speed will pick up, right? Speed increases. So momentum
Yes,
changes.
ma'am.
When you are slowing down a car in the traffic, velocity decreases, momentum decreases. Again, a clear
Yes.
road, you are increasing the speed, momentum increases. So during the journey of a body, is there anything like there will be constant momentum? No. Speed changes, momentum changes. Okay.
Yes, ma'am.
So the change in momentum with respect to time is directly proportional to the net force F acting on the body. Right?
Yes, ma'am.
Now I just take it as F proportional to delta P by delta T. Now you take any object, starting time will be zero, no?
Yes, ma'am.
So delta T means final time minus initial time. Initial time I'm just taking it as 0. T2 I'm just taking it as T. We take it as T2 minus T1. T1 value will be 0 because starting time 0. T2 అన్న తీసుకో, T1 అన్న తీసుకోవచ్చు, T అని తీసుకుంటే better. Okay. Now
Yes, ma'am.
what is momentum actually? Momentum is nothing but mass into velocity. Now you took a car. So during the entire journey of the car, momentum is changing, and the change in momentum is because of change in velocity or change in mass?
Genuine velocity.
Change in velocity, because mass is a matter contained in a body which will be stationary. Mass change అవ్వదు ఎప్పుడు.
Yes, ma'am.
Okay, mass only radioactive disintegrations or nuclear fusion process, only ఆ ప్రాసెస్లో మాత్రమే మాస్ చేంజ్ అవుతుంది. రిమైనింగ్ అన్ని మోషన్స్లో వెలాసిటీ చేంజ్ అవుతుంది, ఆ వెలాసిటీ వల్లనే మొమెంటం కూడా చేంజ్ అవుతుంది. ఓకే. So I can say
Yes.
that the change in momentum is because of the change in velocity, but mass remains the same. M గానే ఉంటుంది, v మాత్రం delta v అవుతుంది.
Yes, ma'am.
So there is a change in velocity, that's why change in momentum. Understood this point?
Yes, ma'am.
So I can take it as delta p will be taken as now m into delta v divided by t. Now delta v means what? Change in velocity. So what do we do? Let us make an assumption. So I'll take a body of mass m. Initial velocity u అనుకుందాము. Force apply చేసిన తర్వాత its velocity increases, let it be v. Okay, so here F applied. On application of force, the body is increasing its speed. Initial velocity is u, final velocity is v. U is initial velocity symbol, and what is v? It is final velocity symbol. Okay, now what will be the change in velocity? Final velocity minus initial velocity. So m as it is, delta v place we will take v minus
V
u
minus U by
divided
T.
by t. Now, what is this term called, Gautam? V minus u by t, change in velocity by time. What do we call it?
Change in velocity by time.
Yeah.
Speed.
Speed, velocity both are same, but speed is scalar quantity, velocity is vector quantity. That's it. Rate
Yes,
of
ma'am.
change of displacement is velocity. Rate of change of velocity is acceleration. Okay. So
Acceleration.
this is m into a.
Yes, ma'am. A formula is V minus U by T.
Yeah. So when you remove proportionality, what will you get? You'll get some constant and RHS MA as it is. I'll make an assumption, let k value be 1. Then what happens? F value
This is
will be equal to m into a.
A.
Okay, so F is equals to m into a is just a mathematical form of second law. But what is the definition of that? This is the definition. The rate of change in momentum is directly proportional to net force acting on the body.
Body. Yes, ma'am.
Is this clear? Any doubt in this?
No doubt, ma'am.
All clear?
Yes, ma'am.
Okay. So F is equals to ma, formula important, remember it. Okay.
Yes, ma'am.
Now what will be the units of force?
Ma'am, Dyne and Newton.
Yeah, Dyne and Newton. So how do we take the units of force from this formula? F is equals to m into a. So let us
kg
take,
by kg meter per second.
yeah, let us take CGS system and SI system. CGS system, mass is gram, acceleration is centimeter per second square. This is simply called as what? Dyne. Instead of saying all the time gram, centimeter per second square, we simply say it as dyne. Okay.
Yes,
Now
ma'am.
MK system, mass is kilogram, acceleration is meter per second square. So you can say kilogram meter per second square, or simply you can say what? You can say
Newton.
Newton. Okay. Now this is important. What is the relation between CGS and SI unit?
10
1 by
power
10.
of 5.
Yeah, 10 to the power of 5 times. Now what about 1 dyne? 1 dyne is equals to 10 to the power of minus 5 newtons.
Yes, ma'am.
Okay, you remember this enough. First one you remember enough.
Yes, ma'am.
Okay. And what else is important? It's about impulse. Okay. Are you clear with this, Gautam? So far, any doubt?
No, no doubt, ma'am.
Okay. Now we'll take the concept of impulse different, impulsive forces different. Okay. So first we'll see what is impulsive force. Okay. So this is a force which acts for very short period of time. Short period of time. Okay. So the force which acts for a very short period of time, that is your impulsive force. ఫర్ సపోజ్ నువ్వు క్రికెట్ ఆడుతున్నావు, బాల్ వేసినాడు, బ్యాట్తో వేసి బాల్ని కొట్టినావు, ఎంతసేపు కొడతావు? జస్ట్ ఒక సెకండ్ కదా.
Yes, ma'am.
జస్ట్ ఒక సెకండ్ బాల్ని అట్లా టచ్ చేస్తావు బ్యాట్తో, అప్పుడే ఫోర్స్ ఎగ్జర్ట్ చేస్తావు. అంటే ఫోర్స్ ఈజ్ అప్లైడ్ బై ద బ్యాట్ ఆన్ ద బాల్ ఫర్ జస్ట్ ఫ్రాక్షన్ ఆఫ్ సెకండ్స్. So such
Yes,
kind
ma'am.
of forces which are applied for very short interval of time, they are called impulsive forces.
Yes,
Okay,
ma'am.
similarly ఫైరింగ్ అ బుల్లెట్. గన్ తీసుకొని మనం బుల్లెట్ని రిలీజ్ చేస్తే ఏమవుతుంది? యు ఆర్ ప్రెస్సింగ్ ద ట్రిగర్ జస్ట్ ఫర్ 1 second and bullet will
Yes.
be released. So there also you are applying the force on the trigger just for fraction of seconds. So that is also impulsive force. ఓకే.
Yes, ma'am.
ఇప్పుడు మనం ఏదైనా తప్పు చేస్తే మమ్మీ వచ్చి చెంపకు ఒకటి ఇస్తది. ఎంతసేపు ఇస్తది? కొడుతూనే ఉంటదా? లేదు. జస్ట్ అలా కొట్టి వదిలేస్తది. సో అక్కడ కూడా ఫోర్స్ ఈజ్ అప్లైడ్ ఫర్ ఎ వెరీ షార్ట్ ఇంటర్వెల్ ఆఫ్ టైమ్. సో that is also what impulsive force. Is it clear
Yes, ma'am.
now? So do you think all the time same magnitude of force is exerted?
No, ma'am.
Maybe sometime 10 newtons, sometime 5 newtons, sometime 2 newtons. It changes, right? For suppose you are applying the brakes on the car during your journey. So do you think all the time you will exert same amount of force?
No, ma'am.
సడన్గా కార్ ఆఫ్ చేయాలంటే ఎక్కువ ఫోర్స్ అప్లై చేస్తావు, స్లోగా ఆఫ్ చేయాలంటే కొంచెం ఫోర్స్ అప్లై చేస్తావు. సో ఇఫ్ యూ టేక్ దీస్ ఇంపల్సివ్ ఫోర్సెస్ త్రూ అవుట్ ద జర్నీ దే ఆర్ నాట్ కాన్స్టెంట్. ఓకే.
Yes, ma'am.
ఇంపల్సివ్ ఫోర్సెస్ డు నాట్ రిమైన్ కాన్స్టెంట్. ఎందుకు అంటే సిచ్యువేషన్ని బట్టి జర్నీని బట్టి దే చేంజ్ దేర్ మ్యాగ్నిట్యూడ్. ఓకే. సో వాట్
Yes,
we
ma'am.
do is maybe at first instant you are applying 5 newtons force, second instance you are applying 3 newtons, third instance suddenly you are applying 15 newtons. So what we do is we take the combination of the entire forces, 5 newtons, 3 newtons, 15 newtons తీసుకోకుండా throughout the journey total effect ని కన్సిడర్ చేస్తాం.
Yes, ma'am.
Okay. So impulse is what? Impulse is a measure of total effect of force.
Yes, ma'am.
We are now taking at a particular point to throughout the journey what is the total effect of force applied on the body.
Yes,
Force
ma'am.
applied on the body. Okay. For suppose నీకు ఏం చెప్పాలి ఇప్పుడు, there is an object. Okay. So forward direction 3 newtons, again forward direction 5 newtons, again backward direction 15 newtons. Then what will be the effect here? 3 newtons, 5 newtons in forward direction, 8 newtons. Backward
Yes, ma'am.
direction 15 newtons. So what will be the resultant effect? The body will
Minus
move. Yeah, 15 minus 8. It will be 7. 7 in which direction now?
left side.
Backward direction. So that's called impulse. That's called impulse. You are studying the total effect now. Different amount of forces are applied, but finally we consider the total effect of force applied on the body.
Okay, ma'am.
Okay, so forces are
Ma'am,
impulsive.
negative right, ma'am.
Yeah, if you are mentioning the direction, so no need of negative. If you don't mention left side or backward, then you have to keep -7.
Yes, ma'am.
ఓకే. సో మైనస్ మీనింగ్ ఏంటి అంటే ఆపోజిట్ డైరెక్షన్. మైనస్ మెన్షన్ చేసినప్పుడు లెఫ్ట్ సైడ్ బ్యాక్వర్డ్ సైడ్ అని చెప్పాల్సిన అవసరం లేదు. ఒకవేళ బ్యాక్వర్డ్ డైరెక్షన్ లెఫ్ట్ సైడ్ అని చెప్పినప్పుడు మైనస్ అవసరం లేదు.
Yes, ma'am.
ఓకే. Clear with this impulsive force and impulse?
Yes, ma'am.
So impulse is denoted by I. It is a force which is applied for a very short time. So what is the formula? Product of force into time.
Yes, ma'am.
Okay, so another formula of impulse is change in momentum. Change in momentum is also called impulse.
Okay, ma'am.
Okay, so can I take one more formula for change in momentum, that is F into T?
Yes, ma'am.
Because if you take first formula, impulse is F into T. Second formula, impulse is change in momentum. So I can take the RHS equal now. Change in momentum is F into T.
Yes, ma'am.
You remember 1 and 2 enough. Impulse is a product of force and time. Because according to definition, you will get the formula. The force which is applied for a very short time. So F into T is I.
Yes, ma'am.
Another concept is it is also equal to change in momentum.
Yes, ma'am.
Okay. Now what will be the units of impulse? I is F into T, right? So
Yes,
F
ma'am.
means Newton, T means second. Sorry, Newton second. Okay. And what will be the
Yes.
CGS unit? Dyne into second.
Yes, ma'am.
Clear? Newton second or dyne second. And remember one more thing, if you take this formula, second formula, impulse is nothing but change in momentum. So according to this formula, can I say that impulse units, momentum units, both will be same?
Yes, ma'am.
These units are according to first formula, Gautam. F into T, Newton into second, dyne into second. Second formula ప్రకారం ఇంపల్స్ మొమెంటం రెండు ఒకటే, చేంజ్ ఇన్ మొమెంటమ్ ఇంపల్స్. సో ఇంపల్స్ యూనిట్స్ మొమెంటమ్ యూనిట్స్ ఆల్సో విల్ బి సేమ్.
That means that only 4 units for
Yeah, you can consider any one. Okay, you can consider Newton second, or SI unit you can consider momentum units are what, m into v, so kilogram meter per second. You can consider dyne second, or you can consider gram centimeter per second. You can consider any one.
yes, ma'am.
First two are SI units, the next two are CGS
CG.
units. Okay,
Yes, yes, ma'am.
any doubt in this?
No doubt.
Okay, now open your textbook. There are some questions given in your textbook, numerical part. We'll do it.
Yes, ma'am.
Did you open?
Ma'am, yes, ma'am. Just 1 minute, ma'am. Just 1 minute.
Hmm.
Yes, ma'am.
Okay, so a force F1 acting on a 2 kg body. Okay, so there is a body whose mass is 2 kg. Okay, so F1 force is acting on the body, produces an acceleration. Okay, so first body M1 is 2 kg mass, and what is the acceleration on it? 2.5 meter per second square. And what is the force responsible? F1 here. Okay, another force F2 acts on another body which is 5 kg mass. This is F2. So here another body mass is 5 kg, and what is the acceleration? Another force F2 acting on a 5 kg body produces an acceleration of what? 2 meter per second square. Find
Yes,
the
ma'am.
ratio of forces F2 by F1. You have to find F2 is to F1. So how shall we do this? You have to find
5
the force. F is equals to what formula?
mass into acceleration.
Mass into acceleration according to second law. So F2 by F1. So I'll take M2A2 divided by M1 A1. What is M2? 5 kg. What is A2? 2. What is M1? 2 kg. What is A1? 2.5. So what gets cancelled here? 2 2 gets cancelled. And
2.
if you see,
2.
2 and of double is 5.
Yes, ma'am.
So 2 by 1, that means 2 is to 1. So this is the answer.
Yes, ma'am. 2 answer.
2 by 1 means 2 is to 1. That's the answer. Okay.
Yes, ma'am.
Now see the next question. Question 2. So a force produces an acceleration of 5 centimeter per second. So acceleration is given 5 centimeter per second square when it acts on a body of mass 20 grams. So there is a body of mass 20 grams. So this is the body. Now force is applied on it. Fine. Find the force in Newton. So first we'll find the force in CGS because the units are given in CGS, right? So first
Yes, ma'am.
find the force in CGS system. What is the formula? M into A. So mass is 20, acceleration is 5, 20 into 5, 100. This is 100 gram centimeter per second square. Can I simply write it as 100 dynes?
Yes, ma'am.
CGS unit. Now you have to find the force in which unit? In MKS system. Newton is MKS unit, right?
Yes,
So
ma'am.
what will you do now? You know 1 Newton is equals to 10 to the power of 5 dynes. So take this 100. In the place of dynes, what you have to do now?
10
1
power
dyne,
9.
exactly 10 to the power of minus 5 newtons. Here the unit is in dynes. You have to convert that into newton. So you have to take 10 to the power of minus 5. Write
Ma'am,
it
1
here.
into 10 power minus 3.
Yeah, 10 square into 10 power minus 5, a power m plus n formula, 10 power minus 3 newtons. Therefore, force in newtons is 10 power minus 3 newtons. This is the final answer.
Ma'am, 1 into 10 power minus.
If you keep 1 or not, that means the same, no, Gautam?
Yes, ma'am.
1 into, if not, both, because 1 into anything is same, no? If you take 1 into x, x only. If you take 1 into 5, 5 only. If you take 1 into 10 power minus 3, 10 power minus 3 only, no?
Yes, yes, yes.
Though you keep 1 hour not, it's the same. Okay. So
Yes.
any doubt in today's lecture?
No, no doubt, ma'am.
So this is what for today. Tomorrow, if possible, I'll take at 6:45. If not, at 7 o'clock. Okay.
Okay, ma'am.
If
Ma'am,
I Yeah, beta.
yes, ma'am. Yes, yes.
If I have any classes, sudden classes are given to me from college, I'll postpone it.
Okay, ma'am.
I'll
Ma'am, you just you'll inform.
Yeah, I will inform. Okay, I'll inform in the evening, Gautam, because till the evening my timetable will not be confirmed.
Okay, okay, ma'am.
Okay. Bye, beta.
Bye, ma'am. Thank you, ma'am.
Bye.